in this video, we're going to talk about subtracting polynomials, and I'm here, Deborah, with Zoe and Zach.
Hi.
Hello.
Okay, so let's do our first example. This asks us to please subtract this polynomial from this polynomial. Now, I want to be careful about the language here. I don't want that one. What it's asking us to do is say, we're going to take this second polynomial, and I'm going to do this out two different ways, so you might just want to watch before you leap to conclusions. And I'm going to subtract from it this entire other polynomial, the first one. And you'll notice here that I sort of lined it up as like this kind of subtraction. So I would argue that we actually want to write it out as a single line, but this is the idea. If we do this, you'll notice that this lines up nicely with the x to the fifth and fifth, fourth and fourth. Uh-oh, those don't line up, so you have to be careful, and the constants line up perfectly nicely too. Okay, so that's sort of the idea, and now let's go ahead and do. Purple okay with everyone? All right, so we're going to actually set this up as one line and then do it out. Let's actually get this sort of out of the way. All right, so we're subtracting the second one from the first one. So 7x to the fifth plus 2x to the fourth minus x squared minus 8. And subtract 2x to the fifth minus 3x to the fourth plus 2x, that's plus, minus 5. Now you've seen adding polynomials or combining like terms, which is exactly what we're going to do. But since we're subtracting this entire one, this entire polynomial, we're actually going to need to subtract each term. Which means we need to distribute this -1 to each term so that we take each one away. All right, so let's go ahead and do that. I'm going to start by rewriting this. Look, I'm about to distribute negative 2x to the fifth minus negative, oh that's plus 3x to the fourth minus 2x minus negative 5, also known as plus 5. Okay? So now we're going to combine like terms. Would you like color coding? Is that necessary?
Sure.
Sure, why not? Ooh, that's the fifth. And so is that. Notice that I underlined the negative also. To the fourth, to the fourth. Let's go yellow. Squared, uh-oh, no squared over there. Red. X, no plain old X over here. And lastly, ooh, my favorite color on the board are the two constants. Okay, so, ready? 7x minus 2x, 5x to the fifth. 2x to the fourth plus 6, 5, oh, another 5, 5x to the fourth. Can we do another one? X squared minus x squared. Nobody goes along with the 2x, minus 2x. And then we have negative 8 plus 5 is negative 3. This would be our lovely, happy final answer. Next. What's different about this one is we now have a coefficient in front that needs to be distributed. And don't be fooled, there's no number written here, but you need to distribute that negative also. I'm not going to draw all the distribution lines, but that's what needs to happen. Okay, I'm just going to do this one out. You guys, Zach and Zoe, are in charge of interrupting me if you have questions. Okay, we'll go for a different color. Great. 12x to the third. Oh, look, I'm distributing. 4 times 2, 8x squared. 4 times negative 4, negative 16x. 4. Now I'm distributing -1. Minus x cubed. Minus 3x squared. Minus 3x. Okay, like terms? Color? No color? Do you need it? Do you want it? No? All right. 12x cubed minus x cubed. 11x cubed. 8x squared minus 3x squared plus 5x squared. Negative 16x minus 3x. Negative 19x. No constant, plain old plus 4. Happiness, done. Okay, so now, in the packet that Kristen gave you, there are two problems that are just like this. Let's do them together. You might choose to pause, do them, and then come back to the video to check them. Do you guys want to do that? Do you want to try them first?
Sure.
Okay, we'll pause the video then. But you guys don't even... Okay, we're back. So this is number 2 from Kristen's packet. And it's much like the one we did before. But before we go and reveal the process, I want to point one thing out, which seems to maybe be a helpful idea. The idea is that if we were to call this f of x, and this one g of x, then really what these instructions are asking you to do is do g of x minus f of x. Are you with me? Okay. So, I should have color-coded that better, but I didn't. So if we start to reveal, then what we're looking at here is, let's see, this whole thing is g of x, and we're subtracting from it f of x. Does that help at all in terms of seeing how that gets subtracted? Okay, so our next move is to distribute the negative here. That's a little bold. Okay, and so that's going to happen next. And if you're watching this as a video and you need it to go slower, pause. So that's the distribution, and I believe here's my final answer. Do we have the same answer? Next, number 3 from Kristen's packet. This time you don't need to line it up, it's already lined up. You do need to do some distribution on both of the polynomials. So that's the first step, is distributing the 3. I just rewrote it. So my step here is that I've distributed the 3 along here, and I've distributed the 2 along here. And then it's combining like terms, collecting them all, and that's the end of the problem. So since this is a movie, it seems to me that we should have a bonus feature. And the bonus feature is to learn how to evaluate a polynomial at a specific x value. I think this is going to make sense. I think it's just the language, the mathy language that's written, and we need to make sure it makes sense to you. Given that this is f of x, so I've defined f of x to be 2x cubed plus 3x minus 1. And I would like to know what f of negative 2 is. Well, that means I'm going to plug in negative 2 for x. Ready? 2. Negative 2 cubed. Look, that took the place of x. 3 times negative 2. Again, took the place of x. Minus 1. And now I'm left just calculating that number. Okay, I chose a negative number on purpose because 2 to the negative 2 to the third would be negative 8 plus negative 6 minus 1, or negative 16 minus 6 minus 1, which is negative 23. That was your bonus feature. And because you want one more thing, here is your homework. These, could you say goodbye?
Bye. Bye.